Hello, this is Kenny Belfato, and today I'm going to demonstrate Solid-CIM. Here's our webpage, sim-tech.com, and our product called Solid-CIM is automatic feature recognition, and I'm going to demonstrate that with the Solidworks assembly. And what this does, it automatically makes layered drawings or DXF files and a cut list. We're going to pick up the part name from SolidWorks. We're going to pick up the material from SolidWorks. And you could also put part properties and put label fields on each part as well. And we'll get all of that information into a cut list. And then one more click to cut and nest the parts with Sim automation. So it's really just going to be a few clicks to go from a full assembly into automatic toolpath and nested parts. Here's how it works. We've got a SolidWorks assembly, and I've turned off or suppressed the hardware features like the Blum features and the drawer slides and things like that. You want to suppress the things that you don't want. There's many other places to suppress things as well or turn them off before you cut them, and I'll show you that in this example as well. We've got some Solid-CIM settings right inside of SolidWorks. And for example, I could ignore things smaller than a 4-inch cube, thicker than 2.5 or thinner than 60 thousandths. You set these settings, and those are things to ignore. You're not going to cut something that's 5 inches thick or smaller than a 4-inch little cube. You can adjust those values. And what it'll do is it'll make drawings or DXFs or both, and it'll put things on different layers. So when it sees a hole in the model, a drill hole, it's going to make a circle on layer hole and it'll be white. It'll make a dado as a rectangle on layer dado. And you could choose these layer names for all these different features that are automatically recognized. So here's the process. You've got those settings. I just showed you those. We're just going to pick this one button called Solid-CIM Connect, and this begins the automatic feature recognition process. Now, it looks like there's, at least 100 parts in this assembly. So it's going to take a couple seconds as it translates the model out of SolidWorks, brings it into AutoCAD, and creates those layered drawings or DXFs. Now, the Sim and Solid-CIM can include its own version of AutoCAD. If you don't have your own AutoCAD, you can get our full license of AutoCAD. It's a permanent license. You don't have to pay yearly or monthly for it. It's a great value. Every CAD/CAM system has commands like zoom and move and copy, erase, draw lines and arcs. We use the AutoCAD version of those commands. It's much easier to learn, much faster, gives you much more capabilities as well. Even if you have SolidWorks, you'll see this integration is seamless. So far, one button click is doing this automatic feature recognition, and it's going to prompt us for the name of the cut list, which defaults to the same name as the assembly. At that point, we'll have all our parts created. Here's the assembly. Go ahead and make that cut list. And there are the parts with the names from SolidWorks, and there's all the names from SolidWorks, and it makes this CSV file. This is like an Excel spreadsheet, and that has the name, the material, and the quantity. Now I right away see some steel in here, and I don't want to cut that probably, some concrete. So what I could do here is just do a sort by column B, which is the material. And I could just get rid of stuff I don't want. Like I don't want that cast concrete, right? Delete that. I see you use some material called cherry ply. And I see another one here just called cherry. So I'm not sure if that should be a different material or the same material. Here's the steel. Let's get rid of that. So I'm just deleting them out of the cut list. Everything else is on a shop ply or a cherry ply material. Okay, and there's the quantity. So there's 8 of these drawer front pieces. There's 4 of these. There's 2 of those. There's 21 of this trim piece. So you have your name of the part, the material, the quantity. There's the panel dimensions. Here they are in XYZ as well. If you want to send this to a panel saw, we can make an artist or cut-right saw file. And then here would be your label information. If you used part properties, that would be your label info. So I just edited the cut list just to show you we can delete things by material there. Okay, and yes, to save that. And I forgot to look at how many lines there were. It looks like there's about 68 individual parts now in this cut list with quantities 10, 16, 2. Okay, so it sees the quantities in there. Now at this point, it's just one more right click, cut with Router-CIM Automation Suite, and it'll start processing these and make the toolpaths automatically. Before I do that, I want to show you the extra features here in the Solid-CIM. There's a button to expand the model, which would do like an exploded view. I'm going to leave that out because of how large this is. It'll just take too long and it won't be a very nice exploded view. If I did it with just one part, it would look a little better. I'm going to pick the lay flat button there. This lays all those parts out flat. So and a lot of people will gasp right there and say, oh my God, that took me forever to do that. And here you can see the automatic feature recognition and what's created here. If we turn on the shaded view, I can erase the solid, for example. And there you can see stuff on layer hole. It's got the diameter and the depth, and it's got the thickness, so Router-CIM knows how deep to cut it. Here's layer outside. And here are some slots. There was something on layer slot, and that's the depth, right? Notice, too, that the dados and the pockets, they're extended past the edge of the part so that it'll cut all the way out. There's a pocket cut. Here's, all of these features are recognized, and you get automatic feature recognition. You could also turn things off here as well. So this little part here is going to pocket in between these two edges. It makes a layer pocket. There's some pocketing going on here and some drill holes. There you can see some extension past the edge of the part for that pocketing, and the part numbers are on there too. So that's the lay flat feature. You don't have to do that, but it's just very neat to be able to do that. You're going to exit out of the AutoCAD, exit out of the Solidworks, and then take that assembly that you just we had, that cut list, and I'm going to pick Cut with Router-CIM Automation. That's going to import this cut list, and it knows the name, the material, and the quantity, right? It knows name, material, quantity. So it imports that, and it's going to apply the tool paths based on those layers. Something on layer hole is going to get drilled. Something on layer pocket is going to get pocketed. Something on layer outside gets an outside type tool path. The automation begins now, and each part opens up and starts making its NC code. I also have it set to do reporting, so there'll be an Excel spreadsheet that pops up each time. And it's also giving me the single part. So I have it set to make single parts and to nest parts. So we'll get both. We'll get single parts and nested parts. So you can see some pocketing and some drill holes happening here. Each one of these is making its individual drawing, and then it's going to go ahead and make the nested sheet as well. So this takes a couple seconds as it processes through those 68 parts. And I already had the material set up. So I already had a cherry plywood. I had a shop ply. And each of those materials has properties like the sheet size, the spacing between the parts, the grain orientation. I forgot to tell you, but look at all these parts. They're all long in the X direction. If you don't do anything, the default is to lay the part long in X. Most machines are long in the X direction. Your material's long in the X direction. That's the default. But you have full control over the orientation of the parts. You can emboss a symbol in SolidWorks. You can emboss a little arrow on the part, and Solid-CIM will know to rotate the part to that angle, whatever angle you had set on that little arrow. It also chooses the side to face up based on the side that had the most machining volume removed, which means if you had dados on one side and counterbores on the other, the dados would probably remove more material than the counterbores, unless you had a lot of counterbores. So the dado side would face up. There's a whole setting on what to do with parts that have two-sided operations. You can either make them as a separate drawing, or you could put everything inside one drawing, and we do what's called two-sided nesting. The two-sided nesting is fully automated as well, and you could put the sheet on the table upside down. It would route all the backside operations on the parts that had them. It trims the edge of the sheet, so you flip it over. It's a nice machined edge on the other side. And then it does the front side. So you could have both front and back sides done on a nested sheet. It makes it much easier than the traditional method, which would be to cut the parts in a nest and then one at a time flip them over. Okay. You can even go halfway through on the back and halfway through on the front. Now, I applaud the designer that made this assembly. The parts look perfect. They had perfect feature recognition. I don't see any problems with any of these parts. We get really good results here. You can see every one of these parts that opens up, makes its tool path. It's all coming out perfect, perfect results there. So you can have, when you model it, if you model it correctly, you're going to get really good results. Now, my pocketing knowledge, I'm using, I think, a 1/4-inch bit for the pocketing, and the slot may be smaller than that. So in some cases, I might need to have a special type of pocketing knowledge for smaller pockets than for larger pockets. And you could do that because the name of the pocket can indicate the width and so forth. So I see this slot right here is not getting fully pocketed. It's because of the tool knowledge I have. Uses a larger tool that can fit in between there. And you could set that all up. I'm using, again, my demonstration knowledges, and all the tool paths you see here are set up on my demo knowledges. So as this is processing, I'm going to wind up with 68 individual part programs. Those are great if you ever need to do a remake. You have the single program already made to do it. Then I'm going to get nested sheets for the cherry and for the shop plywood. I'm going to get, maybe 10 different nested sheets, as well as the 68 individual part programs. I'm going to get labels for all the parts, and you can have fully customizable labels. Then you can put the part properties in for your labels as well. And then I'm going to get reports that give me the cycle time for each individual part, as well as reports for the whole nested sheets. So we get full reporting, full labeling. We get a simulation file too, so you can simulate the tool paths. I've got this set up to do advanced nesting with a stay down type of tool path, where the tool stays down and connects from part to part without lifting up. The single parts still have their outside, but when they're nested, it's going to be all one giant connected together tool path. That can cut your cycle time up to 20%. So it's a great way to save cycle time and get an extra 3 or 4 sheets of material cut in the course of a day. Instead of watching your router lift up and move over and lift up and move over, you can have automatic tool stay down and connect from part to part without lifting up. We can also do common line cutting, two-sided nesting. I can nest by material size, or price, or yield. So I could set this up so I have 4x8s, 5x10s, and 5x12s, and the software will determine what was the best yield. Maybe 2 sheets of 5x10 and 1 4x8. The best price might be 2 sheets of 5x12. So you could put in the price for each size, and the software will figure out what is the best yield or the best price for your nesting results. So I see it's on part 61. Each one of these parts is almost done now. It only takes a couple seconds for each part, and I only did 2 clicks. Really, if I had all of my parts that I didn't want to cut turned off, I would have been able to pick one button to do the feature recognition, then one more button to cut and nest the parts. You saw me open the cut list and remove extra things, okay? If not, it would have cut those. Everything on concrete would have been on a concrete layer or concrete material, and everything on steel would have been on a steel layer. But I turned those all off. So that extra step was a way to suppress things. So here's the first material. It's using 2 sheets. There's an automatic scrap cut. Solid-CIM can cut the remnant and save it for next time, for example. It also has a skeleton cutting as well. So if there's any little leftover at the top of the sheet here, it can chop those up. And I do see some skeleton cuts happening in there. And these are all pretty good yields here. I got there'll be a scrap cut on that last sheet, and whether you save that or not is up to you. And each one of those sheets prints out, and it can print to a PDF file or to a printer or both. You can get a PDF and a hard copy as well. There was the one material that just had that one part on there, so it makes a scrap cut on that one. There was just one piece. Here's the shop ply, 0.5625. And again, I'll get a skeleton cut here, or scrap cut here, and there's a skeleton cut there. So whether or not you save the scrap is up to you. Whether or not you want to inventory it or use it. These are all checkboxes for the scrap cutting. It's got a built-in scrap management system. And again, you'll get these, you'll see the actual usage on your sheets right here. It connects those all together. Now it's just putting the part number on my parts, but you could have it put the part name. So you could have it have the name of the part from Solidworks on each one of those. I like to put those on the label because when you're nesting those, if there's a bunch of small parts together, their name may not fit inside a little part like that. So the whole process completed in a few minutes, 2 clicks. I got all the results for those whole cabinets. We got many nested sheets. It's making the labels now. We got, like I said, 68 individual part programs, and then maybe look like 15 or 20 nested sheets for all those different materials. The results open up, and here's the cherry plywood right here. There's the NC code for the cherry. Each one of the sheets. So there was 8 of those sheets. There was 2 of these. There's the different shop plywood, the 3/4. It saves a PDF file that has all the individual parts in there. And then the nested sheets as well. So these can print out to whatever printer you want, okay? Or they can just go to a PDF file. Your choice. Any of those is available. Okay, so then you got a PDF for everything. You've got each one of your nested drawings right here. So you can edit these drawings and you can make changes to these if you like. Okay, so you can edit these. They're still 3D solids. And if you look at this, you'll see the tool stay down nest over here. I'll put it back in wireframe and move the stay down nest. I pick that up and move it. There's just one lead in and one lead out. And the tool goes past where it started. It has a nice little arc in and an arc out. So this is version 3 of stay down. Before it used to start and stop in the same spot, and that would make a bump on the part. Then we created an overlap that helped with the bump, but the tool had to stop, change direction, and turn. Now it comes along and does a nice tangent arc in and a tangent arc out to the next shape. And this is so much faster by this small little arc that the machine is very smooth to connect from part to part. One lead in, one lead out. That's a tool stay down type of nest. You can edit these nest results too, and you can drag and drop other parts onto this sheet if you like. So if I wanted to, I can come over here and get drawings from another job, and I could just drag these and drop them. Let's see, I can look at them as pictures here, and I just drag it and drop it in here. And let's put that one right here. I can erase this little rectangle and the scrap cut and just dragging other parts in. So you could drag those in. You can use AutoCAD commands on this. So I'm just going to put 2 parts from another job in there and then maybe draw my own piece in here. So I can just use an AutoCAD line command and just draw another shape. And I like to show some potential problems that people encounter, like what happens when you have an ellipse or a spline. Router-CIM will convert those into arc segments, and it makes it much smoother, much easier for you. Your machine is much smoother and easier to run that. Also, if the geometry has any problems with it, because that happens when you get stuff from other people, they draw sloppy, right? How many times you get people to draw like that, and this will fix that for you. Router-CIM will fix it. I drew that in 2D. Here is the Router-CIM button. I'm going to activate Router-CIM. And I have all of my machining commands in one screen. There's a step here. It'll take whatever I select. It'll glue it together, fix the problems, and let me pick where I want my start point to be. Okay. And at this point now, this spline is arcs, much less than a bunch of little lines. And so is the ellipse, a bunch of little arc segments. They're all nice and tangent. And in this corner, it fixed the geometry within a tolerance. It made me a new shape right over top of the old one. Great, it fixed that for me, okay? Now let me go over here and look at this from an ISO view. I can come over and retrieve, how did I make this toolpath? And it was a 3/8 bit in tool number 1, cutting through the material by 3000, so I could just plug in the depth right here, and I could plug in everything right here. There's a nice feature here called corner punch. I'm going to turn that on. Because see how this part had these little bubble fillets? We give you a command to do that, but this part doesn't have the bubble fillets, but that will automatically send the tool into the corner for you. It's a great feature. You don't have to draw the bubble fillets. A circle on the end of this, diameter 0.375, look, it's going to go all the way to the corner here for you automatically. So that'll do that for us. Here I can get the pocketing knowledge off of this one. And maybe I want to use that to cut this circle or the ellipse, right? So if not, I could just take that out, just erase it, right? And I'll switch this to, let's do a helical lead on the inside with the same 3/8 bit. Here's an onion skin. So if I'm cutting, let's go all the way through. Okay, let me put that in there. 0.5 minus 0.5625. And this is an onion skin. So if we pick this, that's twice around the part. So you look at it, even though I drew in 2D, you see the toolpath show up in 3D. So this ramps down to the first level, cuts around, then slides down to the second level, cuts around, and leads out with a helical motion. So the lead in and lead out are following right along the contour of the shape. That's great because it doesn't push on the scrap to move. Twice around the part. It's great for holding small parts, but I have a better way. Here's a better way. It's called the tab at the cut start, and you can put in a percentage. So I'm going to put in minus 0.25, and I'll make my tab 1/8 of an inch high. And what this one does is this leads in and right away makes a tab that's 25% of the perimeter, cuts around, then the overlap cuts that off and leads out. That is 1 1/4 times around the part. Why go around twice? You can go run 1 1/4, and it's the same effect. The tab's going to be held with 25% of the perimeter. I made 1/8 of an inch high so you can see it, right? Normally it would only be like 30 or 40 thousandths high. Here it is 1 1/2 times, and let's do that on the spline. And you can see, lead in, make a tab that's 50% of the shape, cut around, the overlap cuts it off. It's a great way to save cycle time. Again, you could save cycle time. Now, any of this other tool paths, you can copy stuff. Just pick them up and copy them. So if I want to copy this little ellipse, we just pick it up and copy it. Copy the whole part if you want. All right, we copy that a couple times. Put it in a couple spots. Okay, so when you're ready to sequence it, by the way, I've got 3D and 2D in the same nest, no problem. We could sequence this with Router-CIM, put a window around everything, and you could sort. There's all different sorting methods. Sort by area, so it does your small pieces first. I'm going to leave it rank number because I have my, all my drilling is rank 1, then my insides are rank 2. You can have a rank 1.5. Here's the cycle time. And it's done in Excel. It adds things like machine-related downtime to change the dust collector bags, handling, setup time, personal fatigue. It's really going to be about 8.3 minutes. Here's, even though I cut a lot of the toolpath at 1200, sometimes it's only 950 or 700. It speeds up. The machine has what's called acceleration deceleration. And then there's my new NC code file right there. So I just mixed and matched. I took my nest and I dragged parts from another job and drew my own 2D stuff. You can mix and match. That's all done in Router-CIM, and it's saved as a DWG file. No other software is going to give you the move, copy, rotate, erase, zoom in, zoom out, draw lines, arcs, whatever you want to do, drag and drop. Those are all features in the Router-CIM. Here's the rest of the stuff. Here's all those individual parts. So all those individual parts are saved with their toolpaths on them. That's what I used to drag and drop in my other job a minute ago, right? Here's all the labels. You got labeling for all your parts right here. Here's all the labels for all the parts, automatically generated. Okay, you can put the part names. Your part names are fairly long, and so my labels don't quite fit everything on there. I either have to go with a bigger label or a smaller font, right? You can put barcodes if you like, 2D, 3D barcodes. We print all the labels for all the parts. There's a nice feature in labeling as well called touch and print. This shows a picture of the nest, and you touch a part and it sends it to a printer right away. I have mine set to print to PDF. You could set whatever printer you want. And the operator can see the sheets. Here's each one of the sheets for the nested jobs. He can see each part while it's laying on the table, and he just touches it and prints a label one at a time. This is on-demand labeling. So it prints a label right as he needs it. Otherwise, he has to look at the label and see where part number 6 is and stick it there, right? So this is a great feature. It's called Touch and Print. It's under our products, and it's on-demand labeling. It's a nice little optional feature for the Router-CIM. The other information in here is all of your simulations. So there's a simulation file here. This like shows the tool removing material. You can set the speed at which you want to simulate. So it did all that drilling first, or it looked like it did the slots first, then the drilling, then these inside cutouts. And you could pan and tilt this while it's running. Okay, you can look at what's going on there. So there was some more pocketing. That's the order the things were being cut in. So they had the drilling was, slots were ranked number 1. Drilling was ranked number 2. Pocketing is ranked number 3. I can make something that's 1.5. And there's the stay down net. See how the parts, it doesn't complete cutting them yet. It keeps the tool down and connects from part to part without lifting up, and that could cut the overall cycle time. There's a little simulation for each sheet as well. That is called our CutSim software. Okay, so CutSim is a toolpath simulator, and it's a nice feature for simulating if you wanted to simulate. And then the other stuff in here was, you already saw the nested drawings. There's reports. There's a full report for the material. What size used, how many sheets of each material is in here. Okay, it's saved as a PDF. And then the other report is for cycle times. And this is done as either a PDF or an Excel spreadsheet. It does them both, okay? So as a PDF, you can give this to other people. It's got all your cycle times for all the different parts, each single part, each nested sheet, and then what kind of material utilization you got. This is very powerful. So you can find out what kind of scrap area you're going to have yet left, what the total is for your sheets, if you have that. And it's got a great percentages used and how many parts are in there. This is full reporting built in the Router-CIM. It also saves it all as an Excel spreadsheet. If you're an Excel expert, this uses a pivot table, and you could cumulatively save this information. And here it's all put in Excel. Very valuable, useful information from the Router-CIM, all about the job. All the reporting information is in there. And again, everything is saved and ready to go to the router in just those few clicks. Thanks for taking a look at our SimTech software. I showed you the Solid-CIM. I showed you the CutSim. I showed you Touch and Print. We used advanced nesting. We used Router-CIM. All of that from our sim-tech.com webpage. Feel free to give me a call anytime. Our contact info is right there. You can call the toll-free number right here anytime. Thanks so much.